Hello all, welcome to the Embedded IoT Linux for Red Blue Teams course on Pentester Academy. Now in this video, we will continue with looking at IoT rootkits. Specifically, we are going to look at a rootkit which can go ahead and modify process names. So this is still part of step 6. And the network architecture is the same as in previous videos. So let's go ahead and jump right in. So inside the kernel fun directory, we will go into prepend process name. And we're going to look at a file called changename.c. So what is the intent? The intent is on our BeagleBone Black, let's say we run the ps command, we see a list of processes, right? Now let's actually go inside the custom directory which we've used in previous videos, and you should have the bind shell program in there. Let me actually add this directory to my current path so it's kind of easier to work with it. So now let's say I launch the bind shell program in the background. We do a PS. We can clearly see that bind shell is actually shown over here, right? Now what I wanted was, a lot of times if you notice, malware might make it look like, when it's kind of running, then that is kind of a trusted binary. So what I would want is maybe prepending the name with something like, kernel process or something like that, just to make it look a little bit more believable as a legitimate process. There are other things you can do, but this is what we are going to do in this demo. So let's look at how we can do that. Now this is a very simple module to achieve this. And what we do is we go ahead and take two inputs. One is the PID of the process whose name we would like to change. And the second is whatever you would like to prepend to that name. Now based on this, let's actually go ahead and look at our init function. Now in the init function, of course, as you can imagine, what we would have to do is, after we know which process ID we need to kind of go ahead and change name for, we go through the list of processes and then we find the specific process and then change the name, wherever it needs to be changed. So the first step is actually to find and go through the list of processes, right? So this is what we use here for each process P. And P is really nothing but a pointer to a task structure. Now internally in the kernel, pretty much everything is just a task. And the idea is to go through the list of tasks and find the specific PID that we have been told to modify. Now once that is done, what we end up doing is we basically prepend whatever we have entered as the modifier to that existing name. Now if you ask, well, where is for each process, I'm unable to find that. People who are C programmers. Now unfortunately, everything in the Linux kernel, the only documentation is the kernel itself. So you would have to go through the kernel sources to figure many of these things out. Now an easy way, or at least a possible way to kind of figure this out, is to browse through the kernel sources. And there is this site called elixir.bootlin.com. It basically has indexed the entire kernel, different versions. It makes sure that references are drawn between, names of structures, etc., so that you can crisscross and look at details. So first thing, of course, is to go ahead and select your kernel version. So we are using 4.15.7 as of this writing. It's important to select the right kernel version because features change, structures change, anything can change. So it's very important that you are selecting the right kernel version. Now, after that, we can type in for each process, search for it, and we see that it is defined in signal.h as a macro. Let's click on that. And we find it here for each process. This is a macro. And what it does is it basically gets the address of something called init task and then kind of allows you to iterate through it. So what is this init task? We click on it. We see that it is defined as a variable in init task.c. Let's go there. And we see that this is the initial task structure, which is also exported by that file. Okay, so which means that this is giving us access to the list of tasks. Now, what is the next thing that we look at? After that, we have to look at each of the task structures. So let's actually find out where the name is. So I'm going to look at task underscore struct. And looks like shed.h is containing that scheduler code. Now, this is a very, very big structure and pretty much contains every single thing related to a task which is running. So if we were to scroll down and try to find the name of the executable, here it is. You can see that the name of that variable is com, and it is a character array of size task com len. Fantastic. So this is really what we kind of are trying to modify. So now that we have an overall idea about how this all works, let's go back in here. Let's compile this. And then let's actually copy out change name.ko to var lib tftp. And then let's go ahead and fetch it. So we have fetched it. Now, before we run it, if you recall, there were two inputs, right? So we can figure out those inputs by typing in mod info and then change name.ko. So we see that there are two parameters. The first parameter is the process ID, and the second parameter is the new name we would like to prepend. Now, as an example, in the slides, we have prepended the new name Linux kernel to it. So let's go ahead and do that. So as I said, two IDs, process PID, new name. So I'm going to do an ins mod. Let's look at the process ID for bind shell. So the process ID for bind shell is 100. So ins mod change name.ko process underscore PID. This is equal to 100, and then new underscore name. Let's actually stick to what we have on the slides just so that we can be consistent. Linux dash kernel. Let's actually use this. Hit and enter. So notice we have traceback. Again, we could have removed this the D message N1. Now let's actually do a PS. And if you notice, PID 100 has the name prepended with Linux-kernel. Fantastic. And this makes it definitely look a lot more believable, right? For at the very least, better than just having only bind shell. Fantastic. So this is what we wanted to demo in this video. I hope you enjoyed it. Try out the sample program. And if you're enjoying your time at Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you.